Hello viewers, you are welcome to this video lecture. I am here to present the 70th video lecture from chapter 5. Chapter 5 deals about the earthwork quantities and the mass hole diagram. Under chapter 5, the following topics are going to be included. The first is discuss about the earthwork quantities, end area calculations, calculating earthworks, and also will be deals about computing earthwork volumes. The rest will be covered on the next video, the mass hole diagrams, and also will be balancing earthwork using mass hole diagram will be in next videos. So today's will be deals about the earthwork. So earthwork is excavation of material from the cutting and constructing of embankments, which is required to convert the natural condition of the right of ways and configurations into the level that is ready for the pavement workers. So the pavement workers means it is a bed will be the subgrade, so we have fill subbases, bases, surfaces will be as a working will be included in earthwork activity. In key terms will be defined associated with earthwork activities. The first is borrow material. So borrow materials are a material not obtained from the roadway sections, but is secured by widening, cutting, flattening black slopes excavate from the source adjacent to the roadways within the right of way, or will we excavate from the near selecting borrow pits. Waste materials are a material excavated from the roadway cuts but not required for making the embankments, as well as the exceeding material will be as waste material. And also there is two type of hailing, free hail and over hail. So free hail will be the maximum distance which excavated material may be transported without additional costs above the unit bid processes. Most of the projects will be the free hail distances is 300 up to 500 meters. And also will be deals about the overhaul distance. Overhaul distances is excavated material transported to a distance beyonding the free haul distance, or from most of the projects from 300 up to above 500 meters. So there is a cost kilometer per costs. And also will be economical limits of hail, the distance through which it is more economical to hail excavated material than to waste or borrow materials. So this earthwork quantity is limiting through the preparation of mass hole diagrams, as essential elements in providing the best combination of horizontal, vertical, and the cross section designs. So there is very critical the earthwork will be related to the cost. So the cost will be increased. For example, there is vertical curve is very steep. There is a lot of cutting will be purposes, so this cutting will be increase the cost of the project. And also the vertical curve is very steep down, so there is a fill of or selecting material will be filled on the road bed, so this will be increase generally the cost of the project. And the activity undertaken on the earthworks is from the clearance up to the finishing work. So the first one is clearing and gripping. So the first step for construction roads will be clearing the top surfaces. There is unwanted material, organic materials. It is cutting off trace so many unwanted material. So the first one is, it is a cutting sections. Most cutting sections will be paid at a meter square as area. Roadway way excavation is it is different type of excavations. So there is common or soft excavations, intermediate excavations, and hard rock excavations. Most of the hard rock excavation using blasters, and commonly will be excavated by dozers, so many equipments. The other is removal and stockpiling of unsuitable excavated materials of the right of limitations. It is as waste materials. Borrow excavations will be used for the railway filling. And embankments also are constructions from the material obtained from excavation within the right of way or coming from the borrow pits. For embankments for base courses or sub bases, or we have surfaces. And the first step is also will be after excavation. There is sub grade preparation. So this is assessments of sub grade materials, removal and replacement of unsuitable materials, and also preparation of grade road beds. So in the requirement grade elevations, or and also will be taking the elevation, proper elevation. So after that there is a compaction. So compaction means decreasing the mass of the soil, and also will be decrease the volume. So compaction is increasing in density. So density means mass over volume. So increasing the mass, decreasing the volume. And also will be shoulder and side slope construction, and also will be deals about the protection of earthwork. Lastly, we'll have working related to the protection of weathering, protection of waters. So this protection earthwork also will be C. And also a classification of excavated material. So there is different type or class of excavation material. So solid rock, loose rock, and common excavations. So solid rocks, hard rocks, and boulders. Mostly the volume is greater than 1 meter cubes, best removed by blasting. Loose soils also will be it is masses, it is from 0.025 up to 1 meter cube. And lastly will be the common or ordinary type of excavations. There are three types of typical sections. Mostly it is a fill. So original ground level is this one. So the pavement structure will be this part. So this part will be filled. So this part is a sub base, base, surface. So we have a field sections. This one is original ground level is above the structure. So this one original ground level. This one is a pavement. So these parts will be cut. The other part is cut and fill. So this one is like this. Original ground level is like this. So these parts will be fill, and these parts will be cut. So this one is cut, it is this one is fill. So fill is negative, and cut will be positive values. The steps involves in the competition of earthwork quantities and the development of optimal mass of diagrams. The first is end area calculation parts, earthwork calculations, preparation of mass hole diagrams. Lastly will be balance earthworks. It will be the activities. The first activity is calculating the end area calculation parts. These parts will measure two meters. The first one is play meters. These meters will be the original ground lines and template sections. The cross section may be plotted on grade paper. So we have plotting the center line profile grade must be calculated from each cross section and also will be determined the center line references. So lastly will be calculate the area, and we have a table of each sections. Electronic computer methods are used for it is methods will be related to modern computer programs. So we have generally we have give the alignments, the horizontal alignment, vertical alignment, and the cross section. Lastly the computers, the programs will be output will be the earthwork. This area of cutting, this area of volume will be given. And also calculating the earthwork works is mostly commonly calculating the earthwork by using average end area method. This method consists of averaging the cutting and filling quantity adjacent to the stations and multiply by the distance between the stations to provide cube meters, or we have getting the volume, so divided by 2. So for example the consecutive or adjacent stations will be area 1 plus area 2 times the length between the station. Mostly it is 100 feet or 15 feet, so the times by length over 54. We use feet, there is using 54 when we use meter system over 2. This procedure is followed when manual method will be used. So the project designed by a computer will be tabled on the mass plot list and calculates integrated part of the alignments. There is very important will be considered on the calculation of earthwork is the shrinkage and swelling factors. For example, swelling will be when we excavate or breaking up the earths and it make it up more spaces. Afterwards it is swells. Excavated rocks occupy a large volume in filling, and also will be after placing the excavated earths in a field and compacted, the volume will become less than the original. So this value is a shrinkage. So mostly shrinkage is related to the material characteristics. So the material characteristics more denser, the material will be more denser or strong, the shrinkage will be decreased, and soften the material, so the shrinkage will be increased. And also the moisture content also will be, it is dry, there is shrinkage will be or swelling will be less. There is a moisture shrinkage as well as the way swelling is really increase. And climate condition, method of placing also will be related to the shrinkage and swelling. So very important will be consider the shrinkage factors as well as swelling factors. Mostly will be see on the tables. Light excavated soils on ordinary grounds, there is the shrinkage value is 0 up to 20%, and also light excavated soils also will be 20 up to 14%. Heavy excavated soils up to 10% will be decreased. Say heavy excavated means the density will be very high. The excavated rocks, the rocks will be swelling very small amount of shrinkage, so it is 5%. And also computing the earthwork volume methods also will be very important. So the major objective to selecting a route survey in for a given highway, it is minimizing the amount of earthwork. This minimizing the earthwork is related to the amount of the cost. So we have in preliminary a route survey or reconsistency final stages also will be alternate different earthwork. So we have considering estimated or the amount of earthwork is very important. So select or best routes will be low earthwork amount or minimizing the amount of earthwork. To determine the amount of earthworks involved for a given grade lines, cross sections takes at irregular intervals, and mostly will be used 15 feet for increasing the amount of accuracy. And this one is a fill parts. The original ground level is this one, so fill the top parts, the layers, the subbases, bases, surface will be as fill. Cut sections will be this one. This is a structure. This one is a drainage structure. Is a back slope and side slopes will be given. So these parts will be cut. This one is a combination of fill and cut parts. These parts will be as fill parts. This one is as cut parts. So the original ground level is like this. We calculate the volume by using average and area method. This one is the volume is equal to the length between area 1 and area 2. So the adjacent of the areas, A1 plus A2 over 54 volume 1. Then the next volume 2 means L, the distance between A2 and A3, so over 54 in the brackets A2 plus A3. So the next is A3 plus A4, the next is A4 plus A5. So it is a continuously calculation. So there is very carefully is the volume is in effect. In metric systems will be used L over 2, area 1 plus area 2, area 1 as well as area 2 in meter square. It is common practice in earthwork constructions to move suitable material from the cutting sections to the filling section to reduce minimizing the amount of material as borrow material. So comparing the borrow material will be gets from the right of way or the borrow pits. So we have getting the material in the cutting section in the right of way. It is very important to minimizing the amount of costs will be used this suitable material. When the material excavated from the cutting sections are compacted in filling sections, there is a fill less volume than original occupied. So this is a very important is a shrinkage. So this amount of shrink the material or decreasing the volume. As you see as examples, a roadway sections is 2,000 feet long, 20 stations. This is in feet. There is a digit is 2. In kilometer or metric system, the digit is 3. The cuts and fill volumes are to be computed between each stations. The table below lists station number. Column 1 is area, column 2 is volume. So the material in a filling section will be consolidated, so by a shrinkage factor. For it is a given part is 10% will be given. For example, there is 100 yard cube, so this one is multiplied by 10%. This one is 10. So 100 plus 10, the material required will be 110 feet cube. And also will be see first the table. We have also will be use the tables. The tables is there is a station. The second column is cutting feet square. This one is a fill feet squares. Cutting is at 0 station is 3. So 1 station is will be 2. So there is 2000 feet. So it is 20 stations. So the total cutting will be calculated by area 1 plus area 2 times the length. The length will be 100 times divided by 54 will be get 9. So
the other will be the second volume will be it is calculated by 2 plus 2
times the distance. 100 over 54 is 7. The third one is 20. 2 plus 4 it is times by 100 over 54 it is 11. The filling section also will be 18 plus 15 times the distance is 100 over 54 will be 126. The second part is 15 plus 97 times the distance is 100 over 54, 272 will be get. So we have get like this. So lastly the material is shrinkage 10%. So the shrinkage will be related to the fill. Swelling is related to the cutting. So this one is shrinkage. Shrinkage is related to the fill material. So 10%. This 126 times 10% mean it is 12.6. It is rounded into 13. 272 times by 10% it is 27.2. It is rounded to 27. So the total material will be 226 plus 13 once 3 it is 139. So we have adding these parts. So the net volume is calculated as this one is the total fill minus the total cutters. So 139 minus 9 it is 13. 299 minus 7 it is 292. So we have placing the filling sections, and also will be the cutting sections will be use this one. So totally we have also will be calculate the mass hole diagram. So the mass hole diagram 0, it is a fill section is negative. So 0 minus 113 it is negative 113. 113 minus 292 it is 422. Minus 422 minus 451 it is minus 873. So like this. So in cutting sections will be this one plus minus 1327 plus 25 there is minus it is a decreasing value. So mass hole diagram you will be getting this one. So the net volume between the station 0 and 1s, 0 is 113 minus 139 minus 9 it is 113 like this. So we have calculating all on the table. Thank you for hearing my video. Next will be discuss about the mass hole diagram.